Hi, sixth graders. Today we're going to continue our discussion of circles in chapter 11. Today we're going to talk about circumference. Okay, the circumference, which we wrote down the other day, remember, is the distance around a circle. Okay, the distance around a circle is circumference. Well, obviously you can't measure circumference because it is circular. So we'll have a formula. Okay, a formula to find the circumference of a circle. So if you'll get your formula sheet out, we're going to add the circumference formula to that. Okay, so if you go to your next square on your formula sheet, okay, and we're going to put circumference. Okay, circumference is a capital C. Okay, and circumference equals pi times diameter. Okay, so pi times diameter, pi d. Okay, and remember the diameter is actually 2 radii. The diameter is actually made up of 2 radii. So you might also be using 2 pi r. Okay, because sometimes you're going to have to take the radius and multiply it by 2 and then by pi. Okay, so either one of these things, so pi times diameter, or 2 times pi and then radius. That's really just 2 times the radius and then times pi. Okay, so that's going to be our circumference formula. And also, remember that we mentioned this the other day, that pi is approximately 3.14 or 22 over 7. Okay, 3.14 or 22 over 7. So basically, there are certain times where 3.14 is going to be easier to use for pi in a problem, and there are going to be other times when 22 over 7 is going to be the easier thing to use in the problem. Okay, and I'll tell you which one to use, but we're going to look at why sometimes you use 3.14 and sometimes you use 22 over 7. Okay, so first of all, let's look at a circle. And so here we have a circle. Okay, its diameter is 28 meters. Okay, its diameter is 28 meters, and we want to know the circumference. Okay, remember circumference is pi times diameter. So in this problem, I'm going to use 22 over 7 for pi. Okay, 22 over 7. So I have 22 over 7 times the diameter, which is 28. Okay, well, look what we can do. Okay, the 7 and the 28 are going to cancel. So 7 goes into itself, and 7 goes into 28 4 times. So all I have left is 22 times 4 to find the circumference. 22 times 4. So what's 22 times 4? 88. Okay, so 88 meters, and that's the circumference of this circle. Okay, so why do you think we use 22 over 7 in this problem? Well, we quickly noticed that it cancels with 28. Okay, we could have gotten the same answer if we had multiplied 28 times 3.14, but that would have been a much longer process. So basically, anytime you've got something that's going to cancel with 7, you want to use 22 over 7 because it's going to be much faster than doing it the other way. Okay, let's look at another example. Okay, here we're going to have a circle, and we're going to have its radius. Okay, its radius is 5.5 inches. Okay, its radius is 5.5 inches. Well, if its radius is 5.5 inches, we know its diameter is 11. Okay, its diameter is 11. Okay, we wouldn't want to use 22 over 7 as pi because we can't cancel here. And we would have to multiply 22 times 11 and then divide that by 7, and that's a really long process. So we don't want to do that. In this case, it's going to be easier to just use 3.14. So we're going to use 3.14, so pi times the diameter, which is 11. Okay, 3.14 times 11 would be the fastest way to get the answer to this kind of problem. So go ahead and multiply 3.14 times 11. 3.14 times 11, and don't forget in your answer you need 2 places behind the decimal because the problem has 2 places behind the decimal. So 3.14 times 11 and see what you get. 3.14 times 11. Okay, hopefully you got 34.54. Okay, 34.54 inches for the circumference of this circle. Okay, so circles are pretty easy. Basically, if it cancels with 7, I'm going to tell you to use 22 over 7, and if whatever you have in the problem doesn't, I'm going to tell you to use 3.14, and it's just circumference equals pi times diameter, or sometimes you'll have the radius, so you'll have to double it to get the diameter and then multiply by pi. Okay, pretty easy. Well, sometimes you're gonna have parts of a circle to find the distance around. Okay, parts of a circle. So let's see what would happen with that. So let's say that we have this. Okay, and hopefully you remember from the other day that this is a semicircle, okay, which is half a circle. So let's say that our semicircle has this part is 21 meters. Okay, 21 meters. And we notice that if this were a whole circle, okay, if this were a whole circle, that would be the diameter. Okay, that would be the diameter. So let's look at what we would do here. Okay, so again, circumference is pi times diameter. So we're going to use 22 over 7 for pi because it's going to cancel. So pi times diameter. Diameter is 21, so we're going to put 21 over 1. And then at the end, we're actually going to do one more step. We only have half a circle. Okay, we only have half a circle, so we're going to multiply by half at the end. Okay, we only have half a circle. Okay, let's see where we can cancel. Well, we can cancel the 7 and the 21 because 7 goes into itself once and it goes into 21 3 times. But look what else we can do. We can also cancel here. 22 and 2 also cancel. So 2 goes into itself and 2 goes into 22. And you'll notice that all we have left to multiply is 11 times 3, which will be 33. Now, this is the tricky part, or the neat part you need to remember. Okay, remember that the circumference formula is the distance around a circle. Okay, the distance around a circle. Okay, so all we got by doing this math right here, all that is this. It's the curved part of our semicircle. Okay, that's all that gave us was this. Okay, well, we want to know the distance around this. So we still need to add this to it. The 33 is this. Okay, the 33 is this, but we still need to add this to it. So we need to add the 21 back to the 33 to find the distance around. So what would be the distance around this semicircle? What would be the distance around it? Okay, easy. 33 plus 21. Okay, hopefully you got 54. So 54 meters will be the distance around this semicircle. Okay? Okay, let's look at another one. And I'm going to show you how, even if it has a decimal in it, you don't need to let a decimal freak you out. You can still cancel with decimals as well. So let's look at this problem. So we're going to have another semicircle. Okay, and this is going to be 7.7 centimeters. Okay, 7.7. Okay, so we know that it's pi, which we're going to use 22 over 7, times the diameter, which is 7.7. Okay, again, because it's only half a circle, we're going to multiply by half at the end. Okay, we're going to cancel everything we can cancel. Okay, so let's look here. We can cancel these two things. Now, don't let this freak you out. Just think of this as 77 with a dot in the middle. Okay, 77 with a dot in the middle. So if 7 can cancel with 77, then it can cancel with 7.7. So 7 goes into itself once, and it goes into 7.7, 1.1, or 11 with a dot in the middle, basically. And then, just like last time, we can cancel the 2 and the 22. So the 2 is going to go into itself once, and it's going into 22 11 times. Okay, all we have left is 11 times 1.1. 11 times 1.1, and hopefully you know 11 times 11 from memory. 11 times 11. So this is really just 11 times 11, which we know is 121. And then we need one place behind the decimal. So we're going to need that right there. Okay, now remember from last time, all this is that curved part. Okay, that's all that is the curved part. So we still need to add the straight part back to it. So we still need to add the 7.7. Okay, make sure you line up your decimals. Let's add up and see what you get for the distance around the semicircle. Okay, the distance around the semicircle. Okay, pretty easy. Hopefully you got 19.8 centimeters. Okay, 19.8 centimeters for the distance around the semicircle. All right, let's look at a problem that is going to, we're not going to be able to use 22/7 for pi, and it's going to be a semicircle. All right, so we have a semicircle, and the diameter is 20 inches. Okay, the diameter is 20 inches. Okay, in this problem, 20 doesn't cancel with 7, so we're not going to use 22/7 for pi, we're going to use 3.14. So again, we know that circumference is pi times diameter, pi times diameter. So in this problem, we're going to do pi, we're going to use 3.14 times the diameter, which is 20. Okay? Now, remember that I've talked to you about this a couple of times this year, about this little trick about just saving the 0 to the end. So really all you're doing is 314 times 2, okay, 314 times 2, add your 0 to the end of your answer, and then you still need 2 places behind the decimal because the problem has 2 places behind the decimal. So 314 times 2, add a 0 to the end, and then you need 2 places behind the decimal in your answer. Okay, hopefully you got 62.80 or 62.8. Okay, now remember that pi times diameter gives us the entire circle. Okay, so this is if this were an entire circle. Well, it's not. It's only half of a circle. So we still need to divide this by half, or divide it by 2 to know what this is right here. So we need to put 2 into 62.8. Okay, again, because that gave us the entire circle and we just want half of it. So put 2 into 62.8 and see what you get. Okay, hopefully you got 30. And this is easy to do short division because there's not even any remainder. So 2 goes into 6, 3, 2 goes into 2, 1, and 2 goes into 8, 4. And so 31.4 would be the distance around the curved part, okay? And we still have to add the straight part back, okay? So this isn't hard, there's just a lot of pieces to remember. So again, this gave us the whole circle, we still needed to half it. That only gave us the curved part, we still need to add the straight part back. So it'd be 31.4 plus 20, and remember it's 20 point, okay? So that should be easy, so add that up, and we'll get 4, 1, and 5, so 51.4 inches for the distance around that semicircle. Okay, so again, sometimes you're going to use 22/7, sometimes you'll need to use 3.14 because it's going to be something that's not going to cancel with 7. Okay, let's look at something new. Okay, so let's look at this. Okay, and hopefully you remember from the other day that this is a quadrant of a circle. Okay, a quadrant of a circle. So on a quadrant, let's say that this is 28 feet. Okay, now think about this. If this were an entire circle, okay, if this were an entire circle, this 28 feet, that would really be the radius. Okay, the radius of the circle, all right? So let's look what we would do here. Okay, so we have circumference equals pi times diameter. Okay, circumference equals pi times diameter. And so let's use 22/7 for pi. Okay, times the diameter. You could do 2 things here. You could either go ahead and double 28, or you could write 28/1 and then times 2/1, okay? Or you could go ahead and double 28. I'm gonna go ahead and double the 28, which would be 56, okay? And then I'm gonna put it over 1. So pi times diameter. And when we had half a circle, we had to multiply by half at the end. Okay, when we had half a circle, we had to multiply by half at the end. So what do you think we're gonna do since we have a fourth of a circle? We are going to multiply by 1/4. Okay? Now, let's see what we can cancel. Okay, let's see what we can cancel. So we can cancel the 7 and the 56. So 7 goes into itself once, and it goes into 56 8 times. Okay? All right. Now we can cancel, we have a couple of choices here. We could cancel the 4 with the 8. We could also cancel the 4 with the 22. Even though they don't, 4 doesn't go into 22, you can still cancel them by 2 because 2 goes into both. But on this one, since 4, canceling it with 8, we'll cancel the 4 away. Let's go ahead and cancel it with the 8. So 4 goes into itself once, and 4 goes into 8 twice. Okay, so by canceling everything we could cancel, look at all we have left. Okay, all we have left is 22 times 2. Okay, that's all we have left, which we know is 44. Okay, so 44. Okay, so again, the circumference formula, remember, only gives you the curved part. So all this gave us was this right here. Okay, it gave us the curved part. But we want the distance around this quadrant. Okay, we know that this is 28. And again, if this is a radius of this circle, then this is 28. Okay, so we just found out that the curved part is 44. But we also know that this is 28 and this is 28. So we need to add 44, 28, and 28 to find the distance around the quadrant. So 44, 28, and 28. Okay, so add that up and see what you get. Okay, 44, 28, and 28. Okay, hopefully you got 100. Okay, 100. So 100 feet would be the distance around this little quadrant. All right, let's do another quadrant. Okay, another quadrant. So again, it's my 1/4 of a circle. And let's see, let's do one that has 3.5. 3.5 inches. Okay, so again, circumference formula is pi times diameter. Pi times diameter. So we're going to use 22 over 7 for pi times the diameter. And remember, this is just a radius, because if this were a whole circle, that would just be the radius. So that means that if the radius is 3.5, then the diameter is 7. Okay, so pi times diameter, diameter is 7. And remember, because this is only 1/4 of a circle, we're going to multiply by 1/4 when we get down here. Okay, and then we're going to cancel everything we can cancel. Okay, so obviously we can cancel the 7 with the 7 because they go into each other once. And we can also cancel the 4 with the 22. Now 4 doesn't go into 22, but 2 goes into both of these numbers. Okay, so 2 goes into 4 how many times? 2. 2 goes into 22 how many times? 11. Okay, so let's multiply what we have left. On the top we have 11 times 1. And on the bottom we have 2 times 1. So we have 11 over 2, or 11 divided by 2. So what would be 11 divided by 2? Of course, it's something and a half because 11's odd. So 11 divided by 2 would be what? Okay, hopefully you got 5.5 or 5.5. So 5.5, and again, remember the 5.5 is just this curved part. Okay, the 5.5 is just the curved part. So we still need to add these other 2 parts back to it to find the distance around the entire thing. So this is 3.5, and so is this. So we have 2 3.5s. You could go ahead and write 7, or you could write 3.5 twice. Either way, we're going to add the curved part and then add the 2 straight parts to it to find the distance around the quadrant. Okay, the distance around the quadrant. So let's see what we would get. Okay, hopefully you got 12.5 inches, okay, for the distance around the quadrant. Okay, so pretty easy. If you have a whole circle, okay, it's just circumference times diameter, or 2 times pi times the diameter. If you have a half a circle, okay, you're going to use circumference equals pi times diameter, but then you have to multiply by half. okay, because it's only half a circle. And then remember, that's just the curved part. You still have to add that straight part back. And then if you have a quadrant, okay, remember it's pi times diameter, but then you have to multiply by a fourth because you only have a fourth of a circle. And again, that's only the curved part, so you still need to add the straight parts back to it to get the total distance around. Okay, so I think that's everything we need to know about finding circumference and using the circumference formula to also find the distance around semicircles and quadrants. So I will see you next time.